In this online tutorial, we present a visualization of CarMaker via IPGMovie. First of all, we must know how to navigate to the IPGMovie GUI. This is done in the main GUI of CarMaker by clicking on the File menu and going to the IPGMovie option. Now by doing this, we open the IPGMovie window. Now let's have a look inside the applications of the IPGMovie app. IPGMovie basically serves two purposes. The first primary focus is that of an interactive visualization tool, which will be the scope of this training. The second application is that it can serve as a camera SI, which means camera raw signal interface. Since this is an application of others, it becomes a part of the others training. Participants who are more interested in getting to know the others applications are welcome to attend this training and benefit from it. Now coming back to the visualization part of IPGMovie. IPGMovie allows us to visualize the simulation online as well as offline. Online visualization means that the actual simulation is being visualized during its runtime, while offline means to work with the visualization of the simulation, which was already being saved in a buffer. Both are possible, and they also saved as a separate animation data. To demonstrate this difference between the online and the offline simulation capability of the IPGMovie, I have just opened the braking test run from our product examples. Let me start the test run. This test run is now running, and you can clearly see that the simulation status that is being shown here in the bottom of the window of IPGMovie as online. This signals that the simulation is simultaneously being visualized just as it runs behind backend. At the same position, you can select the speed of the visualization and quickly also re-visualize the simulation from the beginning. This is done in IPGMovie. You see here the double of the speed. This illustrates the online and the offline visualization capability of IPGMovie. Now let us also look at the other buttons that are available in the control bar here. The green button indicates that you can re-visualize the simulation, and it's directly connected to the start button of the main GUI of IPGMovie. The other buttons for the right or left from the green play button indicates the jump to the start and the jump to the end button. The start of the simulation is shown when you click on the most left button, and the very end of the simulation is shown when you click on the most right button beside the play button. You can also rewind the simulation if you want to by clicking on the rewind button second left of the play button. And you can pause the simulation via the red pause button. If you want to analyze a specific time step which is of interest, you can directly navigate to that time point by giving the time in seconds and clicking on it if you're using the time menu. When you already want to just slide to a particular location in the simulation, that is facilitated by the option of moving the slider along the slider bar. Let's have a look at the zooming options within the IPGMovie window. In order to zoom in and out, there are two possibilities. You can directly make use of the scrolling options of the mouse, and you can scroll in and scroll out for zooming in and zooming out respectively. Or you can also make use holding the Shift key and also clicking and holding simultaneously the left mouse button in order to zoom in and zoom out. We are moving the mouse back and forth. To be able to rotate a view within the movie display, you can directly click on the left mouse button and move your mouse. Additionally, To be able to shift the view within the 3D environment, you can hold the Control key and move the left mouse button. As next, we will have a look into the other options and functionalities that are available under the tabs of the IPGMovie GUI. The first one is File. Via the menu tab, you can actually load cartoon models with the load options under the File menu. You have also the option of exporting the simulation in many different output formats I show you here, as well in different image formats. However, the requirement for this is that the simulation must be run first. I've already run the simulation once. You can now specify the start and the end time in the export menu. The entire simulation time is around 40 seconds, but here I will only record this as a movie for 3 seconds. I will enter here. Let me click on Start. Now while clicking on Start, the movie is being stored as an MP4 file, which can then be visualized later, and the movie MP4 file is stored now right in your project directory. You can also select which of the available windows you would like to record the movie for. As next tab is the View tab. Here we can see some of the options that are available with a left click. We can create a new IPGMovie window with New Window. The split window functions now also splits that selected window and you can convert it back. Into a single window at any time by returning it to a single view. You can also close the selected window or the other windows via the Close Window option. I'm just going to close the window on which is the new available window here. Then resizing is also an option given in the menu. Here you find different presets. Freeze means that the simulation view is freezed. Here you can select a view. Since the simulation is now started, I would then simply freeze there. You can also return from this mode by selecting the window option again or deselecting the window option so that the simulation continues to run without any interruption. The option Picture in Picture allows you to insert an IPGMovie window into another, as an example here shown. And the option Overlay Right and Left makes the existing additional visualizations like road view cards and the speedometer available in the selected window. You can see the selected window via the company sign from IPGMovie. Then the Show option is basically used to display certain other additional information, such as sensor beams or forces that can be visualized during or within the IPGMovie window. Here, all the modes are activated, and as an example, I prepared a sensor in my car as an object sensor. Here I have a visualization, and I can change also the color of the beam that should be visualized to other color. I have then check is the visualization activated in the sensor, and I have also to activate the sensor itself. If I would now start a test run, we can see that the sensor beam is shown. I now open a test run as an example in which I have a lot of traffic and run it once. If I now call up the view show option, I can activate traffic object names to show the names of the traffic objects in a scenario. This makes it easier for the user to localize the specific traffic objects. For example, if you want to parameterize a scenario with a collision between a vehicle and another object and observe the results. Then we have also here the point cloud option. This option is only used if you are using then a LiDAR RSI sensor in your simulation and you have made the quality settings according to the point cloud option. In this case, the quality settings play a significant role in the visualization quality of your simulation. The user must therefore decide whether to focus on the performance of the simulation or the quality of the simulation. If I were to click on performance, like here, now all these options are grayed out and say that these options are not available. When quality is selected, you can already adjust many predefined visualization settings and details that can be changed and also in the simulation. For example, shadows can be added, like here is already done. And you can also add then reflections on surfaces. This then additional can be rendered much better. If I deselect it, the reflections and shadows will not be higher, shown with a higher quality. You can see differences. You can also use the slider to adjust the quality like you want. If you make the option available, and this will directly have an influence in the simulation and the visualization. As already mentioned, the user must now decide for themselves depending on what is his main objective in the simulation. Last but not least, you have then here in the view settings, the extended settings, where the user can change some of the other parameters deeper than in the visualization that affect the visualization itself. The next tab that is available is Scene. The first option you can call up here is the environment, where you can set the position of the sun and adjust the reflections. You have two possibilities to do so. The first is the explicit definition of the azimuth and elevation angle, either by values or by using the slider. You can here now see that the shadow change depending on the position of the sun. Or you can set the position depending on the location, which is also possible if you change then to fixed position. The option fog is to adjust the fog rate. If you now adjust the fog settings, you can see that the window will also visualize here the fog. The most important point to note here is that the fog option is only considered for the calculation in the case of the LiDAR RSI, while the position of the sun and its reflections is not considered for any of the sensor calculation, except for the camera RSI, as the camera RSI takes the pixel information from the rendered image as the specified frame rate. The next option is to set up a background. There are several presets to choose from, such ocean or night. And I will choose here Fuji Mountain as an example. And to further demonstrate the last option in the tab Scene, you see here, I will first click on Copy Reference Vehicle and then copy current motion data. So the vehicle motion with the default speed of 70 km/h is now saved. Next, I change the driver speed to 50 km/h in our maneuver. And let it run. so that you can see that the model vehicle driver at a speed of 50 kilometers per hour is driving. Next, then, to compare the simulation with both speeds, both the results of the visualization at the speed of 50 and the speed of 70 kilometers per hour, we use the comparison between the primary and the reference vehicle with this option. Already checked. You can already see if I then start the test run again, and we have now here the 50 kilometers per hour. The copied motion data was 70 kilometers per hour, and I will zoom out. You can already see that the two speeds are redisplayed on the same window. The vehicle with the 70 kilometers per hour is now displayed as a ghost vehicle, while the vehicle with the 50 kilometers per hour is the one driving behind and corresponds to the actual simulation run. In this way, you can compare the visualization for 2 or even more runs. This functionality can be used to quickly see how the ego vehicle of the current test run behaves compared to the last one if you change the parameters in the simulation. Now let's move on to the camera settings. We find an overview of the various available options of the predefined views when opening the camera menu. You see here. For example, you can find the bird eye view, which shows the terrain with view of the vehicle from above, or the fisheye view, as an example. These views are set to some predefined parameters. You can find these views in the camera settings. To access the camera settings, you can add a right click in the display field of the movie window, and you see it here. Or click on the menu item camera, then going to settings. In this window, you will find a list of predefined views, and for each of these views, there are a number of parameters that can be seen on the right-hand side of the window and contain curtain values and parameters that are set to a specific preset. In addition, the user can also insert their own view by enter a new view name. And clicking the Add and Set button at the very bottom of the window. And they can actually set the values according to the desired view. The values for some parameters are set using the slider. The slider now makes it easier then to check and define the desired working area for the view settings. In addition, the user has the option of selecting the lens models. You see here. And further parameters for each of these lenses that can be parameterized if you open in the detailed window. This is depending on the lens you choose. Finally, the user can also specify the output format on the basis of which the coloring and output should be displayed in IPGMovie. This was all about the camera settings. Now let's talk about the last tab available in this IPGMovie window, the Help tab. Under the Help tab, the first option is the user manual. The user's guide calls up as PDF file, which is then basically the same file that is called up when you select the IPGMovie option in the Help menu of the main window of the user interface of CodeMaker main GUI. Now here you will find details about the various other aspects of IPGMovie, how to integrate 3D objects, and what are the coloring definitions and informations that are available within CodeMaker, and also cameras are applications of IPGMovie. The second option, which is very important for users, is the 3D object catalog. The 3D object catalog opens the catalog of all geometry objects that can be included in a scenario. Here you have the catalog of all traffic objects. You can also select a catalog of street furniture or a vegetation, which can all be added as part of a scenario, making your scenario more realistic and complex. So this concludes this online tutorial on IPG Movie, and I thank you for your attention. Please feel free to take a look at our other IPG automotive online tutorials for interesting topics.